Now, if we look back at the method earlier, like how we construct our upper and lower bound, it might look very confusing because we have to guess, right? We have to guess what is the number? What is the number over here? Is there any other way to do this? Yes, there is. So how do we do that? All right. Now I'm going to show you a very simple way to find our lower and upper bound by using this over here. All right. This over here, okay, let's see. Oops. I will call this, all right, I will call this my degree of accuracy. Okay. Now, what do you need to do with this degree of accuracy to find your upper and lower bound? All right. Now, the tips over here, when you look at the question, you just have to identify this guy only. Now, what is this guy? They will tell you nearest 10 cm, nearest centimeter, right? Nearest 100 centimeter, or any other unit for that matter. Okay, that is the degree of accuracy. So what do you need to do is to take the degree of accuracy here, and you just have to divide it by 2, that's all. Alright, so when you divide it by 2, what do you get? Now, let's just say my degree of accuracy here, in this case, it is 10. Okay? Okay, my degree of accuracy is 10, and 10 divided by 2, which will give me 5, right? Which will give me 5 over here. Okay, so what do I do with this value over here? Alright, so we're gonna write like this now. For my lower bound, alright, for my lower bound, I am going to use the rounded off value, which is 180 now. Okay, and I will just subtract this value over here. Okay, and I will get 175 centimeter. Okay, and very similarly for my upper bound, alright, for my upper bound, I'm going to use the rounded off value again, which is 180 centimeter, and I'm going to add 5 over here. Alright, and this will give me 180 centimeter. Oh, sorry, 185 centimeter. Okay, now take a look. I've done. That's my lower bound, and that's my upper bound, right? Okay, so that is how you do this. This is the shortcut method. Okay, now with this information now, you are going to write the inequalities now. All right, you're going to write the inequalities now. Now again, when we always write the inequalities, it's always going to be in this form. All right, x is always more or equal than the lower bound, and x will be always less than the upper bound. Okay, and then the final thing you need to do is to fill in the blanks. All right, so the lower bound over here, that will be 175 centimeter, and that will be less than or equals to x, and x will be less than the upper bound, which is going to be 185 centimeter. Okay, now this is the shortcut method to do for any upper or lower bound questions. Okay, now take a look. The answer is exactly the same, right? Okay, but why am I showing you this way? First, because I want you to establish an understanding. How do we get this value, and why do we use this sign instead of this sign? Okay, now when we look back over here now, I hope that you can get the idea already. Okay, again, remember x is less than 185 because we are not including 185. Okay, the maximum value that we can include to describe the height of the tallest player will be this one, right? But of course, writing like this is going to be very messy, so we'll prefer this to round off to 185. But since we round it off to 185, remember, we do not include. Why do we not include it? Because if you round this off to the nearest 10, this will be rounded off to 190. But my rounded off value to the nearest 10 is 180. That is why we do not include it. Okay, why do we include this? Because even the smallest value, 175 cm, when we round this off to the nearest 10, we will still get 180. Okay, so the quick tips over here, just a quick recap. When we want to find our upper and lower bound question, you just have to find the degree of accuracy, divide by 2, and you get the value over here. This value over here will be subtracted and added to the rounded off value. When you subtract, you will get the lower bound. When you add, you will get the upper bound, and then you just have to fill in the inequalities to represent the range of where x can be. All right? Okay, that's all.